So let's look at some of the rules we can use when we're writing net ionic equations. Our first rule is that we can ionize all the strong acids, but we do not ionize any of the weak acids. Now, as a reminder, the strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, that's an I, nitric acid, HNO3, sulfuric acid, H2SO4, and perchloric acid, HClO4. So those are the strong acids that will ionize 100%. On the other hand, strong bases and ionic compounds will dissociate 100%. So a strong base example would be NaOH, sodium hydroxide, and soluble ionic compound will also dissociate. So for example, sodium chloride, table salt. Our next rule is that molecular compounds, they do not dissociate or ionize. So for example, a common one is water. Water, HOH, or H2O, is a molecular compound and it does not ionize or dissociate to any great extent. Another example is NH3, ammonia. Ammonia is a weak base, and because it's not a strong base, it will not ionize or dissociate 100%. And the last rule that we need to know is that polyatomic ions, right, so things like sulfate or ammonium, do not break apart at all. They will remain as SO4 in the case of sulfate, or NH4 in the case of ammonium. So let's look at an example. We are asked to write the net ionic equation for the reaction of sodium hydroxide with nitric acid. So our first step we need to do is write a complete, balanced, non-ionic chemical equation, just like we've done in previous courses. So sodium hydroxide, NaOH, can be written as NaOH, and we have to check our solubility table to find that sodium hydroxide is soluble, so we write the subscript AQ. Reacts with nitric acid, and the formula for nitric acid is HNO3. We check the solubility table, we find that it's soluble, so we write AQ. Now, we have to remember now that our nitric acid is a strong acid. So what will be our products be? Well, it's a double replacement or neutralization reaction, so we're going to get sodium nitrate, NaNO3, and water, HOH. The water, HOH here, is formed from the reaction of the hydroxide from sodium hydroxide, and the H from nitric acid. So HOH, you have to remember, is a molecular compound, and it will not ionize or dissociate to any great extent when we're writing our total ionic equation on the next step. So after we have our non-ionic equation, we can now ionize or dissociate any compound that will form ions. So we had NaOH originally, and because it's a strong base, it will dissociate 100% into sodium ions and hydroxide ions. Next we had nitric acid, HNO3. Because it's one of the 6 strong acids, it will ionize 100% into hydrogen ions and nitrate ions. On the product side, in our non-ionic equation, we had NaNO3, and because it's soluble, so we should put in AQ, it will ionize 100% to sodium ions and nitrate ions. And the last product we had was water, HOH or H2O, and water, being a molecular compound, will not ionize, so we keep water as HOH in our total ionic equation. And then our next step is to cancel any identical entities, any identical compounds or ions that appear on both sides of the reaction. So we notice that we have sodium on our left and sodium on the right. There's 1 mole of each, so they're both canceled out. Then we notice that we have nitrate on the left and nitrate on the right, 1 mole of each, so they're all canceled out, leaving us with hydroxide and hydrogen ion on the reactant side and water on the product side. those are the three things that are left over that we can write for our net ionic equation on the next slide. As promised, here is the net ionic equation. We have 1 mole of hydroxide reacting with 1 mole of hydrogen ion to give you 1 mole of water, the molecular compound. We also have to reduce to any lowest coefficient if necessary. In this case, the coefficients are already 1, but if it was, let's say, 2, 2, and 2, we have to reduce it into 1, 1, and 1. Let's do one more example here. We're asked to write the net ionic equation for the reaction of aqueous barium chloride and aqueous sodium sulfate. So barium chloride, the formula for that is BaCl2, and we're told it's aqueous, so we can write AQ, reacting with aqueous sodium sulfate. So sodium sulfate is Na2SO4, and again we're told it's aqueous, so we can write AQ. Now if we go back to look at the reaction type, we can classify this as a double replacement reaction. So then we know that barium will then be paired with sulfate, so it's BaSO4, and we're going to get sodium chloride, NaCl. Right now it's not balanced, but we can easily balance this by putting a 2 in front of the sodium chloride. We also have to check the solubility of our products. And if we check the solubility table of barium sulfate, we find that it's insoluble, so we can write solid, whereas sodium chloride is soluble, so we can write AQ. So there's our non-ionic equation. The next thing we need to do is to ionize or dissociate anything that can ionize or dissociate. So barium chloride, being a soluble ionic compound, will will dissociate 100%. So we're going to get barium ion, Ba2+, and chloride ion, Cl-, and we notice that there's going to be 2 moles of chloride for every 1 mole of barium chloride, so we put the coefficient of 2. Next, we have to look at sodium sulfate. Sodium sulfate is a soluble ionic compound, so it will completely dissociate into 2 sodium ion and 1 sulfate ion. Remember to put in charges, and as a reminder again, because we have 2 atoms of sodium in sodium sulfate, we need to put in a big coefficient of 2 in front of the sodium ion. Next, let's look at the product side. We have barium sulfate, but as we noted before, barium sulfate is a solid, therefore solids do not dissociate or ionize, so we keep barium sulfate as BaSO4 solid. And lastly, we have 2 sodium chloride, and sodium chloride, being a soluble ionic compound, will dissociate fully to give you 2 sodium ions, which are soluble, and 2 chloride ions, which are also soluble. So there's our total ionic equation. And our next step is to cancel out any chemicals that are the same on both sides. On the left side, we notice we have 2 sodium ions, and they cancel out with the 2 sodium ions on the product side. Also, we notice that we have 2 chloride ions on the reactant side and 2 chloride ions on the product side, so they can cancel out. So then we can finally write our net ionic equation. So now we have barium ion, Ba2+, we should have written the aqueous format here, plus SO4 2-, and once again we should have written the aqueous sign, yields barium sulfate, which is our solid. So there you go, there's our net ionic equation. And just before I finish up my video, I'm going to add in all the signs, all the solubility states that I forgot to have written on here, so that we are complete. I hope that helps you with your net ionic equation questions.